which we talk about, like glacial length or a retreat of snout, there could be various issues in that. Subsequently, we will look into what are the issues in understanding the glacial retreat. So, but mass balance is a parameter which is significantly, not wholly, but significantly influenced by changing climate. Therefore, it is important for us to understand mass balance. And what is the mass balance is all about? It is about the difference between the accumulation of snow in winter and ablation of snow and ice in summer. So you take the difference because generally there is a snowfall onto the glacier, and predominantly in winter and sometime in summer also in the eastern part of Himalayas. So it is an accumulation of snow, and then there is ablation. That means the melting of snow and ice also takes place in summer. So that is the difference between these two is known as the mass balance. In addition to that, if we are on glacier, there could be accumulation due to avalanches and summer precipitation. We are just talk about summer precipitation, and some glaciers in eastern Himalaya with predominantly summer precipitation, they are really influenced very differently. And the avalanches is what really happens is most of the Himalayan glaciers are located in a mountain, and they're in the mountain and adjoining mountain cliffs accumulates some snow, and then it adds into the accumulation or ablation area of glaciers. So that is avalanches, which takes place, and it is definitely influencing the mass balance. Mass can also be lost due to melting of snow and ice in summer, iceberg calving, or sublimation. So we have discussed about snow and ice melt in summer, but what happens is if glaciers are extending into the lake or extending into the ocean, then or a sea, then what happens is there is the calving. That means the whole chunk of glacier ice will detach from main glacial body, and it starts floating into the water, either in lake or either in sea, and then iceberg is formed. Or there could be direct sublimation. It means the solid can directly go into the vapor form, and this is a very high altitude region such as Mount Everest. Sublimation could be an important parameter. So just I was talking about is glacier terminates in water, then block of ice breaks and forms the iceberg. Very cold and dry environment, mass can also be lost due to sublimation, and that generally happens at very high altitude region. It can be also influenced by temperature and snowfall. So generally mass balance, people think it is because of melting, but it is actually both the parameters are important, because the amount of precipitation and the amount of melting, it is the difference between these two is nothing in mass balance. So mass balance can be either influenced by temperature or snowfall. It can be influenced by both. However, the change in mass balance could be important indicator of climate change, as absolute value can be influenced by local geography of glaciers and terrain. So it is important. Many times what happens is, no matter which amount of methodology or which is the methodology you are going to use, and subsequently we will talk about numerous methodologies, but your techniques are standardized and your methodology is standardized, then the absolute value can be influenced by local geomorphology or weather terrain, but it's change over a period of time. How it is departing from long-term mass balance will be really important in the point of view of climate change. So there are different ways to look into this. So the relationship between climate and mass balance is important. So you have regional climate, and it also leads to the local climate. Then you have a surface mass and energy exchange will take place. And some of that is called because of the calving, some of that is a specific balances. Specific balances is nothing but over a unit area. Uh, and and then you can go for entire area and the glacial wide gain or mass balance. If glacier wide gain or mass loss will further influence the glacier area, and glacier area is further going to influence the regional climate as well as local climate. So in a sense, it is a feedback mechanism. That means the climate influences mass balance, and mass balance influences glacier area, and glacier area influences local climate as well as regional climate. So there is a definitely feedback mechanism into this. So what is the mass balance? So specific mass balance is a normally term used in the glaciology, which is nothing but the over unit area. That means how much is change in mass per unit area, how many then meter, it gets converted into meter per unit area. So that is a specific mass balance. So what really, if you look into this diagram very clearly, then you have a x-axis, which is the time. And then you have within the time frame, you have from beginning of winter till the end of winter, and then you have a summer, and then again the winter starts. So when you are in middle of winter, then what happens? Or at the beginning of winter, then the snow starts. Am I audible? Is there any issue?
So
Arya,
you
am I
are audible.
audible?
Yes, sir,
Huh?
you are audible. Yeah, yeah. Somebody else has this thing unmuted their mic. That's why.
Okay, okay. So the accumulation, as the winter starts, the snow start accumulating, and it reaches a peak as the snow comes to end. But however, the accumulation could be higher because in between there could be a small melting will take place. But mostly snow doesn't melt till the end of winter. And when the winter starts, so then there is a uh, total melting will starts, and the melting will till the end of summer melting will takes place. So what really happens is you have total accumulation like this and total melting like this. So this much difference is now annual net balance, right? That is how the net, so amount of snow left at the end of summer is a net balance, annual band balance. So you can look into two different ways into this. One, you can also have a winter balance, and also you can have a summer balance. So it is now many people will do it separately. That means they like to call winter balance separately and summer balance separately. It also means if you look into the accumulation, there is some snowfall is also going to take place in summer. So that is also, this curve is slightly going up. But ablation curve, this curve you can see, and this is identical as this curve, and then this is the left over. This is the end of summer, is the total accumulation. Then this is a summer balance, and then this is a net balance. So we are generally interested in net balance. That is how it is created. But there are really different methods. But if we are working in India, and if you want to do mass balance, there are certain tricks or there are certain convention which is followed in India. So we need to understand one. So the mass balance, if you go into the previous term, what it means is you need to understand how much is the total annual net. But if you go into next year, then in order to identify what was the snow, because certain in accumulation area you have a snow and then you have a ice. So what happens is at the end of summer not entire snow is left, some amount of snow remains there, and then there is a fresh snowfall. So if you next year when you go and you want to know how much is accumulation, you should have ability to identify where was the last year's snow layer, and from there onward you can say this year's accumulation. So stratigraphic method is generally, this is known as natural mass balance method. In this method, mass balance is stable at the interval of a year when glacier mass is at minimum, and this needs stratigraphy of snow to estimate minimum. This could be different than calendar year. So what it means is that you identify last year's this snowpack and how much it is accumulated in this year, on that you estimate. And however, this could be different than calendar year, essentially because every year snowfall is not going to arrive on exact date. Snowfall is going to arrive depending upon various parameters. So one year it could be in end of September, sometime even in middle of August you can have a heavy snowfall. So sometime you may not have snowfall even till the end of October. So it will depend upon then how much is when snow is going to come. So this will be different than calendar year. However, in India, most of it is used as a fixed date. That is, you take it from 1st October to September 30th. Why it is done? This is basically done by Geological Survey of India way back in 30s. And this fixed date, this year, 1st October to 30th October, is used to estimate the mass balance. And this does not require any attention to stratigraphy of snow and relies mainly on mass balance between the fixed dates. So if there is a heavy snowfall in the September, it will go into this year's mass balance and it will not go into next year's mass balance. So if you have a consistent record over a long period of time, it really averages it out and you get some estimates of mass balance. In addition to that, in many regions of Himalaya, accumulation and ablation seasons are not distinct. Peak period of accumulation and ablation may be same. So this is another issue which you will face is, say, if you go into the Sikkim, then there is no, it is more like a Sikkim or Arunachal Pradesh or Bhutan. You have more like a maritime climate. That means there is a continuous, throughout the year you are likely to get snowfall, and throughout the year you are likely to melt it. And you have predominantly a lot of snow in summer, and there is also ablation in summer. And therefore the peak of period of ablation and ablation may be same. That is another issue. In dry season, accumulation and ablation may be less. So you have to be a little bit more innovative in using the fixed date method. Remember, the fixed date method is predominantly used in Western Himalayas. At that time, when Geological Survey of India started, there was very little work in Sikkim, so it is predominantly done in Western Himalaya. So therefore, measurement of specific date can only give net and not the gross values. What it means is gross values and net values you should understand. Net means at the end how much it remains. Gross means you have accumulation and ablation, you have account for all that. That means throughout the summer you know how much is accumulated, and you know throughout the summer how much is ablated. And that will provide you, so you have continuous record of snow accumulation and ablation, and this give you gross values. A net value is you don't know in intervening period how much it is snow accumulated and how much it is melted, but you know at the end how much is remained. Therefore, it is called net value. we need to be flexible and use combination of method. There is nothing which you can do. Depending upon region and climate, you have to little bit flexible and make sure that you use the combination of method. Better technique will be use continuous measurement of mass balance to estimate the gross value. If you can do it, essentially because remember, mass balance is a major exercise. You can't access glacier easily in winter time when it is a thick blanket of snow and the regions are completely, so you have to have some estimate. This is something which is, if you want to get gross values, then you have integration mass loss over a period of time, and you get the total value of mass loss BP. So it is indeed possible for us to do that in this way. So it is important for us to understand how we do the glacial mass balance, and one of the conventional method to estimate the glacial mass balance is a glaciological method. That means you go into the ground and try and get the mass loss by using certain measurements. In order to do that glacial mass balance, what predominantly you do is you put the stakes. This is a Chota Shigri glacier in Himachal Pradesh, and this work was done Wagner and Azam and others. So you can see here, this is an ablation area. Certain regions have very debris cover, and then you put the stakes like this, numerous stakes in various altitude zone. This is a contour, so you get this region is the elevation zone, and each elevation zone you get put the stakes. Stakes are nothing but the vertical pole. You drill it and put it inside the ice. And this is done predominantly in ablation area where ice is exposed on the surface. And then you mark, and you go there at the end of summer, and you know that in conventionally it is 31st September, so you go before that, you measure you mark the glacier surface, you go next year, and again you take out, you find out from that distance how much is glacier surface is lower or melted, and you get a mean by knowing it in different altitude zone. You have then one value for each altitude zone, and you get the total mean. You also go into the accumulation area. Over here you can see, and there is a square. You make a pit. That means you dig the snowpack and make a pit of snow, and then you measure how much is the thickness of snow. At different interval, you measure the density, so you get the total mass of ice. So you do it at different places. However, there are certain issues. So at the end, you have how much is the total accumulation of snow at the end, total ablation of snow at the end, and you get the mass loss. So that is how the conventional glaciological methods is done. But difficulty comes in this, even though you put lot of stakes there, since glaciers are moving, it is melting. By the time you reach there, many of the glacier stakes will be really fallen. That is a practical issue, and because of that, what happens is you may not able to get some years, some stakes will be fallen, they are randomly fallen, and there may not be sufficient data in each altitude zone and can add some error into this. The pits are generally few and far between, essentially because this requires the enormous human effort. You can remember staying about 5,000 meters for a week. If you want to do one pit, you will require one day at least to do the pit and do it. it is very physically demanding work, and because of that, very few pits are taken, and they may or may not represent entire geographical area which we are talking, because we are also discussing about the avalanches accumulation. So the deposition of snow on glacier may not be uniform, and the spatial variability of snowpack is not properly detected by few pits and creating problem. Uh, then addition to that, there is a problem on accuracy of maps, because most of the time maps are old, so its area also changes, and change in surface elevation can also cause some error. So there are certain errors, but historically people have not done error analysis in a conventional method and glaciological method. But then I think around year 2004 and 5, some of us have insisted that you should have this error estimates, and we started to reject the paper. Then only some of them have started to put error into this analysis. So this is also another. Then another issue in this method is mass loss due to calving. So what you really look into this is a Samudra Tapu glacier in Himachal Pradesh, and you can see this ice which is completely detached from main body. So if you consider whatever loss is caused because of the calving is not accounted in the stake and pit method, making this is adding some error into the result if there is a mass loss due to calving. So there are, and you also know that glaciological method is very demanding. That means you have to stay on the glacier for weeks and months, and you require very large infrastructure to support scientists on the glaciated height and bring them back safely on the ground. So as the end result of this, you have a method which can be applied for very few glaciers. On top of that, glaciological method cannot be applied for large glaciers, because you have not in position to have, suppose you take the Gangotri glacier, which is more than 100 square kilometer area, and you might reach thousands of stakes. Of course, you are not positioned to have that stakes and measure it. So you tend to take a small glacier, it is 4 or 5 square kilometers in size. You tend to take it near the roadhead, where you quickly go and come back. So this creates the biased information about the glacial health. Therefore, there are numerous techniques have been developed now to estimate the mass balance. And one of such technique which is extensively developed by me over a period of about 20-25 years, and it is now commonly used, is the equilibrium line altitude method. So we will look into this method, but let us understand what is the scientific principle behind this method. So first understand the glacier what it is, and glacial surface. So if we are in very high altitude regions, or in a region where Siachen you go up to 6,000 about 7,000 meters, if you go to Mount Everest region, then that is called a dry zone region. That means in this region there is no melting of snow takes place. Correct? That is why it is called. So in Himalaya there is hardly any dry snow zone. It is predominantly dry snow zone can seen in Antarctica and Arctic region. Then what happens is below that there is a percolation zone. What it means is there is a some melting on the surface takes place, but that water which passes through the snowpack refreezes it again. And since it refreezes, it increases its temperature, and because when the refreezing is an exothermic reaction, and it increases the temperature of snowpack. So there is a, but entire melted water is consumed by snowpack to increase its temperature. Therefore, this is called a percolation zone. But there is some point where there will be water which is melted on surface reaches at the bottom, or bottom means at the ice pack or ice which is glacial ice, and entire this region, snow region, converts into 0-degree isotherm. That means this is because here there is a melting snow, and melting snow is at 0 degrees Celsius. So this develops. So this becomes a wet zone. And then as you come down, then there is a line, there is a snow line. That means snow will end. That means there is the end of ablation area, and then the accumulation area will start. Then another thing happens is there will be some region where superimposed ice will be there. So what superimposed ice is nothing but the snow is in process of converting into the ice, but some of that is very large chunks of snow or ice will be there. In Himalayas, because I have got many, I gone to the many glaciers in Himalayas, and I have gone to the many glaciers in Arctic. But in Himalayas, there is no superimposed ice. So equilibrium line, which is at the end of superimposed ice, and from where glacier ice surface starts, gets shifted. So snow line becomes a equilibrium line as far as Himalaya is concerned. So that is how the importance of equilibrium line. So what it other way means is that if you can identify snow line into the Himalayan glaciers, and which is much easier to do, then you can clearly identify the equilibrium line on the glaciers. But what is its characteristic? How do you do it? But there is another way of looking at the equilibrium line. This is one way of looking at the equilibrium line. So what it means? It means if you apply this principle, it means that the snow line, which is at the end of, if you can identify snow line at the end of summer, then this becomes a equilibrium line. That is the idea. But there are other ways which people have tried to interpret or estimate the snow line. It means if you plot a mass balance, annual mass balance versus altitude, and you plot the graph like this, wherever it cuts into the zero mass balance, then it becomes the equilibrium line. So this is the equilibrium line. So this altitude, some year you have equilibrium line about 5,000, slightly less than 5,200. Some year you can have equilibrium line slightly above 4,800. So this is how you can do if you have a glaciological method. So essentially now you have two definitions of equilibrium line altitude. One definition which is done by conventionally, where you estimate the mass balance, and then the mass balance representing zero, representing the zero mass balance is a equilibrium line. However, this equilibrium line could be we may not be able to identify on satellite images, but this equilibrium line where snow line represents equilibrium line is possible for us to delineate images. So this is how way back in 90s we have interpreted snow line and equilibrium line, and that was really accepted, and some of the high profile papers published in Journal of Glaciology, and many people still use this definition to estimate the snow line and mass balance. So having said that, how do you estimate the equilibrium line altitude? It is snow line. As summer progresses, snow will start melting. You can see year 2001. As summer progresses, snow line will start melting, and ice will be exposed on the surface. You can see here, ice is exposed on the surface. Ice will be exposed on the surface, and if world is ideal, this should go on retreating backward. This should go on retreating backward, and it should retreat till the end of 30th September, and you are able to get the mass balance. You know the position of snow line, and you have mass balance, which is estimated by conventional method, which is the 30th September. You correlate it, and you get the mass balance. That is the original idea. However, you can see into this data, and you will see that this is a WIPS data and this is a WIPS data. It has around 56 meter resolution, it has around 60 meter resolution, and you can see that 28th August. So it is this, you may not get all the time satellite images which can provide you good estimate. There's another issue in this is what will happen to ELA if ELA is above the maximum glacial altitude. What it means is, you can see into this picture, except this small region, and here it is mostly it is a cloudy. There is no snow on the glacier. That means entire snowpack is melted away, and there is a ice which is exposed on the surface, and therefore it is now you have a position where there is no area above the equilibrium line, and that means there is no accumulation area, and glaciers are not in position to form a new ice, and this leads to the decapitation or terminal retreat of the glaciers. So how it looks like ELA, you can see this is a ice and this is a snow, and you can see how equilibrium line looks like on this. So once you have an equilibrium line, then you can convert this equilibrium line by using glacial area into accumulation area ratio. So accumulation area ratio is a ratio between accumulation area to total glacial area. So why AR is related to mass balance is a very important thing. So you can see here in accumulation area, this is with time, the more snow is accumulated. So this is how this is, the curve will with time, how it looks like it is more accumulated, but it is melted less. So you have a certain amount of accumulation. On equilibrium line, you have balance. That means amount of accumulation is equivalent to amount of ablation. And in the ablation area, you have accumulation, and then you have, so you have total ablation is higher than total accumulation. That is how they are linked with each other, and therefore it is possible for us to do that. So if you convert AR into mass balance, you require some relationship between the accumulation area ratio and mass balance. If you are living in idealistic world, and remember our mass balance is estimated on 30th of September, and if you have a satellite images which systematically gives you a retreat of snow line, and you are able to detect the snow line at the end of summer, then you can plot, you can correlate this and get the mass loss. This method is an advancement in understanding Himalayan cryosphere, essentially because until now this method was well developed in 1990s, and subsequently first paper was published in 1992 or 1993, and then there are numerous programs were launched. So first time we got glimpse into what is happening to glacier on large scale. Until now, mass balance was restricted to only 1 or 2 glaciers in entire Himalayas, And people were trying to make some conclusion about that. And because of that, IPCC's 2007 confusion came because of very limited data which is available for one or two glaciers, and they want to extrapolate for entire mountain range and making mistake in doing that. But this technique first time has provided you opportunity to look into thousands of glaciers in one go and provide its mass balance. However, we know that two things we know by now. So one thing we know is all about we require satellite images, which is at the end of summer. But there is some difference between the end of summer and the mass balance which is available in India. Indian mass balance is available 30th of September, so end of summer need not be close with that. So it creates it, and then because of the cloud cover and because of the unseasonal snowfall, you may not be able to get the snow line which is at the end of summer. So what you do? Now, even the original technique was developed in mid-90s. You can see subsequently one of my doctoral students had developed this technique where she had used two important ideas to improve it further. First thing is we have winter precipitation, and you estimated the accumulation model. You estimated in each altitude zone how much is a snowfall or snow accumulation. You have a temperature, then apply temperature index model and get ablation in each altitude zone. So once you have this, you validate it for which there is no for certain period of year where there is no snowfall, and then you run it till the end of September, and you get the imaginary equilibrium line of September, and then from there you got the accumulation area ratio, and you get the annual mass loss. This model has the advantage because it can be forced with the climate models, and it can give you future changes in ELA and future changes in mass loss. So this is a much better method to do it now, and I'm sure some of you will do exercise on that. Advantage in this method is it is predominantly, if you look into that, it is predominantly based upon the temperature and precipitation. And satellite data is going for the validation purpose. So you can run it for a period which you have a satellite, you have a temperature and precipitation data, and it is quite possible that you have a large, and you can do it annually. You can do for hundreds of glaciers by developing programs, and this is how she has done it, and she has estimated annual change in mass balance from 1985 to 2009, and this work was done. You can also have spatial variability of snowfall, how temporal and spatial mass balance of basin during 85 to 2016. You can really do that. And you can also see for some year mass balance is very negative, some year, so you can understand the trend. You can also do the not only over a period of time, but spatially how it is changing. And you can see here the blue is showing very relatively less mass loss, but some glaciers are having very little mass loss, but some glaciers are having red tone is showing very high mass loss, clearly suggesting that there is a special heterogeneity in mass loss. And some glaciers, so we know now that small glaciers which are located low altitude regions are likely to face significant mass loss. So we can detect that, and we can understand how glaciers are going to lose the mass in future. We can also plug it into the climate model and say that how climate model is going to change in future. how temperature and precipitation going to change in future, and if you can, some models suggest by middle of century 1.5 degree rise in temperature, some are saying 3.5, and then you can plug into the model and say how glacial mass loss is going to change in future, how it is going to accelerate in future. So all kinds of further analysis you can do, and I am sure some of you, these exercises you will do in today afternoon. There are another method to understand glacial mass balance is geodetic method. What this method is, this is an indirect method to determine glacial mass loss. What essentially you do in this method is you develop a digital elevation model where you get the surface elevation of glaciers. After a couple of years or few years, you again develop the DEM, and then the difference, by differencing the DEM, you get the glacial change in thickness, multiplied density, and you will get the mass loss. So you can best accomplish by differential glacial GPS system or satellite taken by optical or microwave region can we do it. So this is one satellite picture where you can estimate mass balance by geodetic method. Is a Cartosat satellite image, and this is there are two, one forward looking, one backward looking cameras on the same satellite, and you can take the two pictures. When two pictures are there, you create certain model, and then you get the parallax, and by knowing parallax you can estimate the elevation. If you have a historical DEM, you can use the historical DEM, or you can use so what it gives is a relief displacement. So you can see here on this picture is if photograph is taken exactly vertically down, then the bottom and top of the surface should be at same place, and depending upon its shift, how much this is this position, top is this position, both the position actually should have been on one spot, but they are not there because there is a shift. That is shift because satellite has taken picture by angle, and it has created the parallax. Now this parallax, or you call it as the relief displacement, using characteristics of the glaciers, characteristics of the sensor of satellite, is altitude, various other things, you can generate the DEM, and you will do that. So you go into the field. If you want very accurate, then get the GPS points, the mass balance into, this is one which we are done in a basin, where you gone into the field, collected the points, and then use it in satellite images to estimate the change in elevation. So you can see here observed elevation changes from 2000 to 2014, how elevation is changing, you can say from, and this will help you to get the mass balance. Another method to estimate the mass balance is called the gravimetric method, where the GRACE satellite uses the microwave. So what essentially it is the GRACE satellite is essentially measuring the gravitational pull or gravitational field of the Earth, and it has the two satellites which is flying at around 220 kilometers above and 500 kilometers above the Earth. And when it comes to the places where and there's separation as it moves through the on the surface of the Earth, depending upon gravity, there is minor perturbance which takes place, and these minor perturbances are used to estimate gravity anomaly, and that so it is used to estimate the change in glacial mass. There are still a lot of accuracies in this, and you can see the GRACE data of glacial mass loss. This is very high accuracy in high mountain Asia, but methods are significantly now improving, and hopefully we will have better result. So what essentially, if you look into the overall mass balance, you have a first method, which is the glaciological method, which gives you mass balance about individual glaciers. Um, uh, More people rely on this because you put a lot of efforts in doing that, and that is you get the small glacier. You have another method, which is a geodetic method, which by using change in elevation you can estimate mass balance. And you have third, so these two methods, one method is for individual glacier, geodetic method you can do it for large geographical area. And the GRACE method will give you estimate for entire mountain range. So you can use this method in different spatial domain. Accumulation area ratio will provide you information on individual glaciers also. It can fill the gap. Suppose you are not able to go 1 year to glacier because of some other reason, you can fill the gap by using accumulation area ratio. You can also get it on a basin scale by hundreds of glaciers doing that. An advantage in this accumulation area ratio is you can predict mass loss of future also. So that is so it depends upon what is your purpose and what you want to do. You can choose the mass balance method which you want to choose. With this, I would like to thank you all, and so there are some questions that you can we estimate true AR from transient snowline using activity index? Activity index is a ratio of change in snowline. Can we estimate ELA from snowline using temperature index? And what are the advantage of AR method for mass balance? So these are the small things you can look into that. With this, I would like to stop and take some questions if